to the Coders Campus podcast, where you'll learn how to code from one of the best teachers in the industry. Whether you're an absolute beginner or a seasoned pro, the Coders Campus podcast will teach you what you need to know to master the art of programming. And now, your host, Trevor Page.
Ladies and gentlemen, boys and girls, children of all ages, welcome to this episode of the Coders Campus podcast. It's episode number 10, and welcome. This is going to be an episode that shouldn't come as a shock or surprise to any of you. It is a continuation of our previous episode, number 9, where we were talking about some of the cool toys that we can use inside of the Java 8 platform or language version, however you want to look at it. So in this episode, we're going to be diving into what a stream is in Java, or rather streams, because it's always pluralized, streams. So first and foremost, let's talk about why you should learn about how to use streams, right? Because, you know, why should you even listen to me? Why is this episode important to you? Why should you care? Because it's a great question that you need to ask. You should always ask, is this worth my time? Should I really be learning about whatever it is that this teacher is trying to teach me, right? So I'm going to try to convince you that you should listen, because this is a relevant topic that will make your life as a programmer better. All right, so having said that, streams in Java 8 are essentially the solution to aggregating data easily. Okay, so I guess we can sort of back up a bit and say, well, what the heck do I mean by aggregating data? And I would say that you need to consider a database query that uses aggregates. So in SQL, in the structured querying language, which comes along with databases, the aggregates that we have access to are operations that can be performed on groups of data. Okay, that's the whole point of aggregation, is grouping data and then performing operations on that group of data, like counting rows, summing values, finding a min or max, or maybe getting an average of each of the groups, each of the buckets. And that's the whole point, when all these operations can be performed on data that is grouped into buckets. Okay, that's what grouping and aggregation is all about. Well, really grouping, that's what it's all about. Aggregates is performing operations on those groups of data. So if you're not familiar with the concept of aggregate functions and all that stuff, I've definitely done articles or written articles, blog posts on this, and created podcasts about this. You can go to the Coders Campus website and type in, you can look for SQL aggregate functions or SQL group by, and you'll find the articles there. But anyway, the whole point is streams, not only do they help when it comes to grouping and aggregating data, it also helps in terms of the speed at which you can perform these operations. So you might be thinking, well, do I really care that much about aggregation? Do I really care about grouping data and stuff like that? Well, fair enough. That's a good question to ask. But I'll give you an example of some fairly common things that happen inside of, let's say, pre-Java 8. So maybe we can say Java 7. Some things that we do with Java 7 that would make our lives much easier with the Java 8 streams. Okay, I've started to use streams now, and I love them. They're a little bit difficult to get to know, to get to learn, to understand. So, I'm going to try my best to explain this stuff. But once you have a grasp on them, they're really quite cool and powerful. A lot can be said and done in very little code. So pay attention. So, okay. Streams, they're great for data aggregation, however you want to say it. So we're going to talk examples. So let's say we have a game. And the game has players. The player is an object, and players have high scores. So we have a player object that has a bunch of properties, one of which is a high score property. They also have location information inside of them. So maybe city and state, but for now, for simplicity's sake, we'll just say a state that they live in, or maybe a region if we're living in a country that does not have states. Perhaps we have a country that has provinces, maybe like Canada or any other, well, not any other country in the world, but some countries in the world. Anyway, so now if we want to get let's say we want to get the top high scores for all the players that live in all the 50 states in the USA or something like that. How would we do this with Java 7 level coding skills? Okay, i.e., not using a Java stream. So we would have to get aggregate information of our data without using streams. So first and foremost, like I said, if you go to the Coders Campus website, you can go to coderscampus.com/3 EP10, because this is episode 10, and you'll see all the code that I'm about to talk about. And the reason why I mention that is because I'm going to skip over the code in terms of saying it out loud, because it would be kind of ridiculous to go through and say all the code out loud. So if you can, open up, if you're listening while you're at the gym or something like that, not when you're in a car, but or at least not driving. If you're driving, you're going to have to deal with this. If you're not driving, then pull out your phone, go to coderscampus.com/10 right now, so you can follow along with the code, or if you're on your computer or what have you. I'm sure you're a smart person, you can make that decision on your own, but absolutely do not do this if you're driving, because you're going to be having to look at your phone a lot, and that is just not safe. So, first off, we have the player class. Okay, like I said, players are an object, players have properties. They have an ID, a high score, a state, which is the state they live in, and a name. I'm omitting city from here just because, you could put city if you want, but we're not going to use city in any of our coding right now. But, when you have a state, typically you have a city. You might even have an address. Who knows? And then we'll have all of our getter and setter methods for all those instance variables. And maybe we'll define a toString method so that we can output the player objects nicely. So if we put the player on the console, it'll do invoke the toString, and it'll, tell us the name and the state and maybe the high score of the player, instead of just giving us a meaningless, representation of its memory address location when we do a print line on it, or a toString on it. So there you go. That's just the player object. And now what I'm going to do is I'm going to create an application, and the application will have a, public static void main method. And inside of this public static void main method, we're going to do a print line, a system out print line on a method. We're going to have a method called, let's say, get high score, or high scores without streams. Okay, that's a nice long descriptive method name. So get high scores without streams. Again, this is implying that this is how we need to go about getting high scores without the use of the Java 8 streams. So without the use of streams, we'll need to break down each step of the process for finding the high scores in each state, step by step. So the first step is to actually get some player data. So we need to make sure that our players list is populated with data. So we're going to also have a players list, which is a list of player object. Let's call it an array list, let's say. So somewhere in your code, you need to instantiate a list of players as an array list. Call it players. And then, this step 0, if you will, is to populate that list of players with data. So I have some data that I just populated it with. I think I have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different players. And they belong to 1, 2, 3, 4 different states. So I have 10 players playing in 4 different states. The states that I randomly chose were Arizona, Washington, Colorado, and California, for no specific reason at all, other than me looking at a map and saying this one, this one, this one, this one. And then I've assigned high scores to each of those players. Okay, and I've also obviously assigned a name to each of those players. I got some inspiration out of the Game of Thrones, as well as Lord of the Rings, and maybe some comic books, to get the names of the players that I created just for fun. You can see that again. coderscampus.com/10 gives you access to all the code. So we have 10 players that we've sort of populated into our list of players. Although you could also be getting this list of players from a database. Up to you, whatever. This step, the step 0, is going to have to happen in either case, whether you're using streams or you're not using streams. Doesn't matter. We need to have data in some way, shape, or form. By some manner, you need to get the data. So, fair enough. Step 1 for getting the high scores per state without streams is we need to create a hash map. We need to create a hash map that maps has a key of a string, which is the state. And the value of the map is the list of players. So why I'm doing a string as a key and a list of players as the value for the map, key value pair, is because the string is the state that they are as living in, if you will. So the key is the state, and that's what we're grouping by. Remember, we want to group by state. So naturally, we're going to have a map that has the key of a string, which is a state, as the key. That's how we group. So we group by state, and each state will hold a list of players that belong to that state. So if you want to group, or if you want to execute, the methodology or the Java 7 methodology, the non-streams way to populate this map, we need to iterate through each of the players. So we can do a for each loop through each of the players, right? We have a players variable, that is our list of players, and we're going to iterate through each of them. And what we're going to have to say is, we're going to have to check and see if our map, remember with the key value, the state, the string as the key, and the list of players as the value, we're going to have to check that map to see if it contains a key of the player's state already. Okay, if the map contains that key, let's say we've already placed someone from Arizona into the map, then all we need to do is get from the map we need to execute a .get, and we pass in the player's state to get the value or values inside of the map, and then with that we add another player onto the value, which is the list of players. So we're just adding another player onto our list of players in our map. Otherwise, if there is no key, there's no state in that map yet, then we need to put that state into the map. Okay, so we say, get the map.put player.getState, and we instantiate a new array list of players, and we insert the player into that list. Okay, again, difficult to explain over audio, but really all we're doing is we're putting data into our map in the way that we should be putting the data into our map. We're grouping it by state and putting the players in there. So there we go. That's step one. We've done it. It took about, 1, 2, 3, 4, 5, let's call it 6 lines of code. If we were writing it with brevity, if you will, 6 lines of code to populate our map. So now, once we have that map, we need to sort that map. So it's a map that's grouped by state. We need to sort that map with the player data by high score, and then return the highest score for each bucket, if you will. Okay, so for this, we need to maybe create a sorted map, is what we're going to call it. So it's we'll call it sorted map, but it's a linked hash map. And we're using a linked hash map because order matters here, right? Because we want to be sorting this guy, so order matters. And maybe we can also create a list of players called high scores, which is another array list. And this is where we're going to be placing each of the individual players, the highest score player from each state, we're going to be putting into this list. So we'll have a high scores list, and that's what we'll be adding our values into once we've sorted our map and everything, our linked hash map. So we instantiate those two objects, and then we need to essentially iterate through our grouped data map that we created previously, right? When we went through and used those 6 lines of code to group, to map the data to put the data into a map that is grouped by state. We need to iterate through that now. So we can do we call it, let's say, a grouped player data by state map. Okay, so we need to iterate through the grouped player data by state map. So in order to do that, we do the name of that map .entry set, and we that's part of our for each loop. And our for each loop is map.entry string list player, call it an entry. We iterate through the grouped player data by state map.entry set. Horrible. I'm probably completely lost you at this point. All you need to know about this line of code is we're going to be iterating through the data that we had grouped. That's all we're doing. We're iterating through it. So as we iterate through it, we need to be able to sort each of the buckets, right? So each of the buckets, let's say we have the Arizona bucket, the Washington bucket, the Colorado bucket, and the California bucket. Okay, 4 different buckets that in each of the buckets we have lists of players. So we have 4 buckets, each with their own lists of players. Okay, so we need to go through and we need to sort each of those 4 buckets. Okay, so in order to do that, we do a collections.sort. And then we can, do an entry.getValue, because the entry is what we're going to be looking at. The entry is what contains the map, the entry is the map that contains the key and the values. So, we could sort by value, because that's what we want to do, sort by value. So we say collections.sort entry.getValue. So that will mean I want to sort those values. And again, the value in this case is the list of players in each of the 4 buckets. Okay, and then we want to say new comparator, or we can use our lambda expression. Although I said we're using Java 7 here, so I guess we can't use a lambda, expression. We need to use Java 7 terminology. So that would be a new comparator, compares on player. Then we need to, implement the compare method inside of the comparator. So we need to override the compare method, and pass in our players and do player 2 get high score compare to player 1 get high score. All the stuff that you would normally do when you're creating a comparator to sort by high score. There you go. That's what we would do. And then once we've done that, once we have sorted the entry, what we need to do is we need to put. Now, do we need to do this in my code? I'm putting data into a sorted map, which is the linked list, and I'm putting in the entry.getKey and entry.getValue. We might not need to do that one. That might be redundant code. I'm not sure. Anyway, because what we really want to do is, once we sorted the collection, once we sorted the buckets, all we want to do is we want to grab the value, the element that is, I should say the player. We want to grab the player that is in the first entry, the first index of the value for each of the buckets, right? Because the first entry, the first player now should be the one with the highest score, because that's what we just sorted by. We sorted it in such a way that they were in descending order, so the highest score is at the top in the first entry, the first index. So that's what we want to grab. We want to grab that, add it to our high scores list of players. All right, so maybe we don't need a sorted map after all. Maybe that's sort of just redundant code that I didn't realize it's there that probably should be deleted. So actually, let me go and do that right now, just because I want to, give you guys the right stuff inside of my actual post, my blog post. So I'm going to go through and look at it, and it looks like, okay, Colorado, it looks good. That data looks correct. Okay, so that was useless code. So let me go and update my my actual code in my example in my blog post at coderscampus.com/10. I'm going to delete that sorted map because it doesn't need to be there. And I'm going to also delete the instantiation of the sorted map, and we can just forget that ever even happened. So there you go. Through the magic of live recording, I've done that. So anyway, that was, let's see. So we have the 6 lines of code that we did before, and then this is also an additional 1, 2, 3, 4, 5, 6, 7, 8 lines of code. So we'll call that 6 plus 8, 14 lines of code to get to be able to return a list of players that is sorted. Well, that is in each have the high scores for each of the states. Okay, so good Lord. That took me a long time. That was almost 20 minutes of explaining that code. And like I said, 14 lines of code. It's a lot of work. Okay? It's a lot of work without streams. But that's how we had to do it before we had streams. So now let's introduce the data aggregation with streams. So thankfully the alternative now is stupidly simple. Okay? Stupidly simple in terms of it's not much code at all, but there's a lot going on inside of it. So I guess it's not simple. I guess it's easy, not simple. Is that the right way to say it? Anyway. Well, first, let's have a look at the code. What the code that we would need to use for the desired output, and then I'll explain the actual code itself. So what I'm going to show you or talk to you about here is the one method that will do the work we need in order to return the list of players. Okay, so this method can be called from, let's say, our main method that we had, that I talked about in our code example from before, that when I was talking about our main method, right? So anyway, we'll create another method called get high scores with streams. Okay, so previously we had get high scores without streams. Now we're doing get high scores with streams. So all we need to do is we can immediately just say return. We're going to return something, and what we're going to return is players.stream. So remember, players is our collection. players is our list of players that we have pre-populated in step 0. So again, we will need to populate this somehow. There needs to be a step 0 here to populate our players variable. But once we've done that, we can do players.stream. Okay, so you can invoke a stream on a collection. Now, I should say an iterable collection. Okay, if the collection is iterable, then we can invoke a stream. So we can say players.stream, and then we say .collect. So we say .collect, and I'll explain all this in a moment. So you say .collect, and then you say collectors.grouping by, because this is our grouping thing going on, and we pass in a, what's this called? We pass in a method. There's an actual word for this. Method instance. There we go. We pass in a method instance, which is denoted by the syntax player with a capital P, which is the object, :get state. So we're passing in the method get state. And then we say comma, and we say collectors.max by, because we want to get the maximum of those grouped players by state. And we pass in a comparator. We need to do a comparator. We could use a lambda expression here, but you can also use comparator.comparing. And then you pass in another method instance or method reference. Reference, that was the word. Method reference, not method instance, method reference. The method reference we're passing in here is player, :get high score, and then we do .values. And then that's it. We're done. We've got everything that we need to do. Now, I blew through that really quickly. There's no way, if you've never heard of streams before and never worked on streams before, then you have no idea what I just said. That was complete Greek, and that's fine. So obviously, there's a lot going on inside of the code, but that's why I'm here to try my best to explain what's going on inside of the code that I just explained. Now, starting from the top, the first thing I actually didn't say and I should have said is that the method here, the get high scores with streams method, returns a collection of optional of players. So you maybe have never heard of the optional keyword before. Okay, you might be scratching your head over it. The optional keyword was also introduced in Java 8's version 8. I'll cover that topic probably in the next podcast episode. We'll go into optional. For now, all you need to know is that there may or may not be a player object inside of the optional collection container object. So optional is just a way to sort of mitigate the null pointer exception issues, which is kind of neat. And like I said, I'll explain that later, but all you need to know is, when you have an optional player, it means it could have a player inside of it, or it could be empty. Okay? So, having said that, let's actually dive into the stream method, okay? So, this is the method that you call when you want to start the process of creating a stream from your iterable collection. Okay, again, I say iterable because the collection has to be iterable to do a stream. I think because you can't have a map and do a stream on a map. Let me just double check my logic on that. So if I say group, or if I look at one of my maps and say .stream, you can't do a stream here because I don't think it's iterable. But maybe you could do a stream on the entry set, because the entry set of that map might be entry set.stream. Yeah, because the entry set is a set. So a set is streamable because it's iterable. Anyway, I just wanted to get that in my own mind to make sure I understood that myself. So where was I? In this case, so we have the iterable collection, and in this case we have a collection of player objects. And this is the collection that we want to actually start streaming. So stay with me here. Don't lose me. Don't fade away. This is important now. We're talking about streaming. I just talked, like I said, a whole bunch about the way to do it without streaming, and that was long and boring, but now this is the exciting part. So snap out of it. If you're not paying attention, pay attention. So again, we have a list of player objects, and we want to start streaming that list. So once we start our stream using players.stream, there are a few things that we can do to our data. Sometimes you'd want to filter the data, maybe, so as to eliminate data points that you don't care about. But in this particular example, we're not going to do that. We're not going to filter because we want to consider all the data points, right? We essentially want to filter by the max, but you can't do a filter with that. So I'll show you an example about filtering next. Maybe the next episode, because this is going on fairly long. So maybe I'll have to draw this out to 2 episodes to talk about streaming. in any case, what we want to do here is we want to group our transactions together by some sort of criteria. Okay? Or maybe I should say by some sort of criterion. Because I think it's anyway, it doesn't matter. In our example, we want to group by the player's state. So the criterion in this case is that we want to group by player's state. So this is accomplished by first executing the collect method. Okay, so we say players.stream.collect. Okay, the collect method is actually usually the last operation that you perform in a stream, though it obviously isn't evident from this example because it's like the only one that we're executing here. But again, I'll show you more examples probably in a future episode of how we would probably do more things before we do the dot collect. But we're going to, in order to do this, we need to do the dot collect so that our data, it's going to be, so that it can be returned to our collection of players, because you want to return that list of players who are, one from each state who has the highest score in each state. So we need to tell Java how we'd like to collect our data. Okay, it's not enough to just say .collect because that's all great and grand. But if you just said .collect and nothing else, then we would just essentially return the existing stuff inside the map, and we would just stream that, or rather inside the list, and we'll just stream it into another list. In other words, nothing's going to happen. We're going to stream essentially the same thing into our list of players, and that's not what we want to do. So players.stream.collect. And then, let me see, where did I just scrolled up in my notes, and I lost my spot. Here we go. So in order to collect our data such that it will be returned to our collection of players, we need to tell Java how we'd like to collect our data. So we tell Java we'd like to group our data together using the collectors.groupingBy method. Collectors.groupingBy. Okay, because we want to group by something, right? So that's what we can do. Collectors.groupingBy. You can think of the collectors keyword. It's important. It's a utility class. That's sort of how you can think about it. It's got a whole bunch of static methods that can be used to help us tell Java how we want to collect our data. So more often than not, I would say maybe even in every instance when we do a .collect on a stream, we are then inside of the collect method going to be using some sort of a collectors dot something, right? So collectors.groupingBy, collectors.toList, collectors dot, etc., etc. There's a whole bunch of different static methods that can be invoked using the collectors utility object, if you will, utility class. So it's really cool. We're going to be using it all the time. So when we initiate the collectors.groupingBy method, we need to tell it how we'd like to group our data. Okay, so we know that, we want to do a grouping by, so we want to group it somehow, but how do we group it? We need to tell it how to group it. So we say collectors.groupingBy, and then as a parameter, we pass in a method reference. So we do player : get state. Okay, method references, I should say, they're also a Java 8 thing. They come from essentially like a Lambda expression. It's sort of like a Lambda expression, but you're literally just passing in the reference to a method. Okay, so it's like you're passing in the reference to the method without having to actually invoke the method. Because if we said player dot get state, that would invoke the method. So we say player : get state, and what that does is it just passes in the reference to that method. So now our collectors.groupingBy has the method, the getState method, so it knows that, I need to use this in order to do what it is that I need to do in order to group the data. This is the parameter that we are grouping the data by. We're grouping it by the player's state. All right? So almost done. Not yet, though. Now we're not done with the grouping. But if all we wanted to do was just group our data by the player's state, then sure, okay, fine, we would be done here. That would be the last step, and we'd be happy. But we don't just want to group the data by state and return that. We want to get the maximum value inside of each of the buckets, inside of each of the states. All right. So luckily, the grouping by method, the collectors.groupingBy method, can also take a second parameter. So the first parameter we've already given it, which is the player getState method reference. So the second parameter is called the downstream parameter, which performs what they call a reduction on the data. So all this means is that we're going to reduce the number of returned data points in some way, shape, or form. Okay? For our purposes, this reduction is going to reduce the data set to just the maximum value in each bucket. In other words, we're performing the aggregate function of max. Okay? Max is the aggregate function that we're performing. This is what we're performing in the second parameter of the collectors.groupingBy method. A lot going on here, I know. Again, looking at the code makes it a bit easier, but there's still, even looking at the code, this is still pretty complex stuff. So, well, how do we tell Java, that we'd like to reduce our data to just the maximum value, though? We haven't actually done this yet. How do you do it? Well, lucky for us, we have a collectors.maxBy utility method. So remember, collectors.groupingBy, collectors.toList, collectors.maxBy, collectors. There's a whole bunch of different collectors utility methods that we can use here, and one of those just happens to be .maxBy. So we can use that. We can say the collectors.maxBy method takes one parameter. We can use it, and it takes one parameter, and that is the comparator that it takes. It takes a comparator, I should say. Okay, so there's a lot going on here. Again, collectors, if you go back, let me reread the code that we have looked at so far. We do a players.stream, so we're going to reiterate what I've already iterated over. We're going to do players.stream .collect, because you want to tell it how to return stuff, .collect. What are we collecting? We're doing collectors.groupingBy. We pass in the method reference of player :get_state. And then the groupingBy method takes a second parameter, which is the downstream parameter. Remember, I'm saying downstream parameter. The downstream parameter is the collectors.maxBy. Okay? The collectors.maxBy method takes a parameter, which is a comparator. Okay? So this is where I'd said before when I was going through the code before, you could pass in maybe a lambda expression for your comparator, because we talked about comparators using, we talked about lambdas using a comparator as an example in the last episode. So we could use a lambda expression here if we wanted to. So we'd pass in, open bracket P1 comma P2, lambda symbol, which is the arrow, and then we pass in the body, which is P1 dot, what would we say? Get high score dot compare to P2 dot get high score is essentially what we would do. But we can do it even quicker here because we can use something called the comparator dot comparing method, and it's another utility method like we have with collectors dot whatever. Here we can do comparator dot comparing method. So you can just pass that method. With the comparator.comparing method, you just pass the method of the class you'd like to compare on. Okay? So previously with a lambda one, I said p1.getHighScore.compare to p2.getHighScore. So in this case, the getHighScore is the method that we're comparing on. So this is what you would pass in to the comparator.comparing method. Okay? So we would just pass in player, so it's a method reference again, player : getHighScore is what we would pass in. Okay, gee, I know it's a lot of talking, very difficult to visualize, but I'm hoping that maybe you can listen to this and you can go to coderscampus.com/10, look at the code, and then listen to this again while looking at the code. Although you can probably save some time by just looking at the code right now while I'm talking. But hey, it never hurts to go over the same lesson twice. That's perfectly fine because this is complex stuff. So we'll use the comparator.comparing method and pass in the player : get high score as a method reference into the comparator.comparing method, and voila. It will do the appropriate comparing in order to order the stuff in such a way that we will get exactly what we want. So it will automatically compare values highest to lowest. Now, if you wanted to go in reverse order, then you can append .reversed onto your comparator.comparing method. You can say comparator.comparing player : get high score .reversed, and that will reverse the order of your comparator. But anyway, now that we've done that, finally, now that we've told our collect method, we've told it how we'd like to collect our data, which is the grouping by, blah, and then max by, and then with the comparator, we're left with a map of strings. Okay, and the key is a player state, and the value is the list of players, right? So, because remember, we grouped lists of players by state, So that's exactly what we're getting back after we've done our collector call. Okay, we grouped lists of players by state. So we have a state with a list of players, but now we've grouped it together, and essentially all we should have in the value part of that map is just one entry, which should just be the maximum, or not, I should say one entry, which is the player that has the maximum high score in that bucket. Okay, so what we truly want to end up with, is not a map. We want to end up with a list. Right now we have a map with string and a list of players, even though there's only one player in the list, but we want to end up with just a list. So the question is, how do we get the values from a map? Well, it's simple. This is not from Java 8. We can do this in Java 7, maybe even down to Java 5. We can say, we can invoke the .values method on our map collection. Okay, so if you use map.values, you get the values of the map. Instead of the keys of the map, you get the values. Voila, we have our result set. So essentially, this is 4 lines of code that you could really all put into 1 line of code if you really wanted to. But for the sake of, well, this really is 1 line of code. But for the sake of seeing the code properly, to understand it nicely, I've sort of exploded it out into 4 lines, and now we're done. Okay, so you can compare 14 lines of code of the old way to essentially 1 line of code with the new way. Okay, and that's both the upside and the downside to Java streams. They're efficient in the terms of execution because it's much easier to execute on a stream, and I'll explain that in a second. And it's very concise, right? It's a very concise way to write the code, but there's a lot going on in the background that you really need to understand because, like I said, there's a lot going on in those, essentially, that 1 line of code. It took me 40 lines of text or, maybe 15 minutes of talking to explain what's going on in that 1 line of code that can be broken down into 4 lines if you want to make it more readable. But yeah, there's a lot going on there. So that's both the upside and the downside. But like I said, once you really start working with streams a lot and get used to them, it's pretty neat using them. It's pretty neat. It's pretty quick. And let me get back to what I was saying before in terms of efficientness of execution. It's a lot more efficient because you're only going to be performing the operations on the entries that you need to be working with. So, for example, in the next example that I'm going to be getting into in the next episode, I'm going to be diving into, I guess I won't be doing the optional keyword in the next episode. Maybe that'll be the next episode. But in the next episode, I'll be diving into an example where we're filtering a list of players. Okay, so we can filter by some criterion where we can filter whatever, that list in some way, shape, or form. So when we're filtering, we actually reduce the data set, and then we are only the downstream functions that we're applying or the downstream actions that we're going to be implementing on that collection. There's going to be less to execute on. There's going to be less data points that we need to actually do something with because we filtered. All right. Whereas if you could compare and contrast that against the Java 7 or previous way, we have to iterate through every single one of the players in the list in order to eliminate the ones that don't meet our filtering criteria. Okay, so if we were to filter by, the state that they're in or something like that, we have to iterate through every single one and check the state. Does this person live in, let's say, Arizona is the one we want to filter by? Do they live in Arizona? No? Okay, go to the next one. Does this guy live in Arizona? No? Okay, go to the next one. Does this guy live in Arizona? No? Okay, you know what I mean? You need to go through every single one. But when it comes to streams, the filtering mechanisms that it has are much more efficient than going through one by one in a particular order too, because we are inferring order. We are essentially enforcing an order when we iterate through our list of players. We're saying start with the first one and go all the way to the last one and check each one in a specific order, which is not as efficient as being able to say, okay, Java, I have this collection of objects. I don't care the order in which you filter these by, just filter them. Okay, it's kind of like giving the example I heard, which is great, is kind of like giving your friend a stack of envelopes or envelopes, depending on how you want to pronounce it, and you say, okay, with the stack of envelopes, I want you to mail all these envelopes. but I want you to mail them, to put them into the mailbox in a particular order by, let's say some arbitrary condition like they're, by first name or something, or by last name, who knows. So you give the collections to your friend. Your friend walks over to the mailbox and says, I really need to go through this entire stack and look for, Adam, and then mail Adam, and then go and find Bob, and then mail Bob's, and then go and find Christina and mail Christina's, and go and find Dave and then mail Dave. No, they're going to take the whole chunk and just shove it into the mailbox, right? That's essentially what's going on with streams. We're allowing our friends to shove everything we want into the mailbox, okay? Instead of arbitrarily imposing some order to that, innately unordered operation. Look at all these words coming out of my mouth. I sound so smart. Anyway, that's, I shouldn't say that. Anyway, I probably won't edit that out because I think it's funny. I'm a funny guy, ladies and gentlemen. So that is essentially where the big advantages come with streams is they don't impose any order, and they're faster. Take my word for it. They're faster. And I didn't even talk about paralleling streams. Shoot. You can even put streams in parallel given some circumstances, but that's definitely a much more advanced topic because you need to understand what can be parallelized and what cannot be parallelized. And also doing a parallel stream on a small data set doesn't necessarily mean that it's going to be faster than doing it sort of synchronously. So if you have a small data set invoking the parallel stuff, there's a lot of overhead to it. So it only really works if you have a collection of items that's 10,000 items or more, I think, is when parallelizing streams comes into play as being more efficient. But yeah, if you're working with big data here, parallelizing streams using a parallel stream, which is essentially like saying multi-threading. You're allowing multi-threading to happen on your stream at the same time. All these operations can happen at the same time. That can really increase performance drastically over, again, imposing an iterable order over your streams or over your collections. So anyway, really, really cool stuff. I should have been talking about this ages ago, but I only now being able to have the time to get around to talking about this stuff. So really, really interesting stuff. I've had a lot of fun learning about this, and obviously I'm having fun teaching it to you as well. So I will wrap up by saying check out the show notes at coderscampus.com/10. You will see more than just what I talked about on that page. You'll see more examples of other things, but those examples I'll talk about in episode 11, I guess. All right, cool. So, as always, happy learning. Take care of yourselves, ladies and gentlemen, and bye for now.
Thanks for listening to this episode of the Coders Campus podcast. But before you go, Trevor has a favor to ask you. In order to keep these episodes free, he'd love for you to leave a rating and review the podcast on iTunes. Just go to coderscampus.com/review to leave your own rating and review of the show. So if you have 30 seconds to spare right now, please help out by leaving a rating and review via coderscampus.com/review. It will ensure that you continue to get these awesome free podcast episodes each and every week. So if you like free swag, head on over to coderscampus.com/review. Happy learning!